Okay, so my name is Carlos Mariscal, and the last time I ran this through, it was 13 minutes, but I cut out the 90 seconds where I just stare you guys down, so I think we'll be fine. Okay, so my topic is what universal biology should be. Now, you're probably wondering what universal biology is, let alone what it should be. So there's a reason we don't think about biology as universal, and it goes back to this guy, who in 1859 wrote this really great book in which he argued, among other things, that there was common descent, that all creatures on this planet ultimately trace their ancestry back to some last universal common ancestor, Luca. So in a sense, we're all related. We have a sample size of 1, right? Now, before this, it was reasonable to suppose that biology was as universal as any other science, like physics or chemistry, because you had millions of species. You could generalize over them. You could figure out interesting patterns and make interesting conclusions. But once we realize that this is the case, we're in this kind of weird, precarious situation. Now, very few other sciences, if any, are in this situation. Not even psychology is in this situation. Like, in psychology, you could do comparative studies with chimpanzees, for instance. The closest I could think of was Egyptology, which isn't really much of a science. So this means that we're all alone, and that everything we're generalizing over, everything we're trying to figure out about biology is done in this context of a single example. Nevertheless, a lot of people have thought that they could general or universalize biology and come up with just the parts of biology that are expected to apply everywhere, everywhen, to every evolutionary system. So these are a couple of the people that have tried this. The most recent group that is at least claimed to try to do this is this nice little group of, they call themselves astrobiologists, and I met a bunch of them at the bar yesterday. They're great. So I'm just going to read this a little bit. So, we must move beyond the circumstances of our own particular origins in order to develop a broader discipline, universal biology. We need to exploit universal laws of physics and chemistry to understand polymer formation, self-organization processes, energy utilization, information transfer, and Darwinian evolution. So these are all my emphases. And I'll get a little bit more into this. So this was a promissory note. Not very much has been done on this front since it was proposed. But before I get into this, I'm just messing with the camera. I'm just making you have to move it around. Okay, so before I get into this, we need to start talking about what is biology. And a lot of people think that this means that you have to define life, but there's very good reasons to think that we will never succeed in defining life. I personally think that there is this continuum between abiotic and biotic factors. And so even attempting to define life is equivalent to trying to say that there's a distinction between red and orange. Yeah, there is, but where do you draw the line? There's no justified place to do it. Luckily, it doesn't matter. I think there's a more interesting way of carving nature at its joints, to use the old phrase. So the things that really matter aren't, life kind of captures it, but I think the thing that we need to focus on is evolution. I think, so the Dobzhansky Maxim is that nothing in biology makes sense except in the light of evolution. And I think that astrobiologists haven't taken full advantage of evolution. There's a lot of power in evolutionary theory that is very helpful. So going back to what we saw, just messing with this camera, going back to the definition that the roadmap proposes, it said that we need to exploit these universal laws of physics and chemistry. We take physics and chemistry to be universal. But it's interesting that much of what biology is functional. It's defined by what it does, not what it is. So there's lots of ways to realize certain concepts in biology. And I'll give a couple of examples right now. So even though life is based on chemistry and physics, the really interesting stuff occurs under a variety of different configurations, right? So now from here, it doesn't necessarily follow that there's no necessary universal laws of biology. It's just that they're gonna be different. And I prefer to instead think of this in terms of recurrent causal mechanisms. It took me like 20 minutes to make these this morning. I couldn't find them online. So gears, for those of you that can't tell. Okay, so recurrent causal mechanisms, I think, is a better way of approaching this instead of trying to figure out how to scale up from laws of physics. And this, I should probably justify why I said that biology is at least partially functional, and a lot of things in biology are defined functionally. So take, for example, the concept of wings. It's not just a cheer spin-off. I don't know why I leave these jokes in. I need to, God, I have a problem. Okay, so there's butterfly wings, there's bird wings, there's dragonfly wings, and then there's the bat wings. All of these evolved separately, parallel evolution, to solve the same designed problem to how to fly. Now, there's also multicellularity, for example, has evolved 25 times in the history of life. Eyes, this thing here, those have evolved at least 40 times and probably as much as 65 times in the history of life. So there's something there, there's something about the function role that things play that is how we should start approaching universality in biology. So this is what I propose. We should think of universal biology as a set of all interesting evolutionary models which make no reference to any contingent effects on Earth and so are expected to obtain elsewhere in the universe. This talk is based on 2 papers, by the way. Email me if you want them. One of them is more of a literature review, and one develops this a little bit more and justifies my use of all of those words. Okay, so for structural things that are based on it, that are in biology, based on physics and chemistry, maybe just approaching it the way NASA, the roadmap approaches it is fine. But for other things, we should probably focus on these universal, these design problems that are expected to obtain everywhere in the universe, like resistance to radiation, perhaps fidelity of information transfer might be another thing. And this is not the kind of thing that can be done by one person. This is probably the reason why it hasn't been done by one person, even though a lot of people claim to try. This is a discipline-wide effort, which is why I come here to you today. Okay, so what it should be, we should seek out these broadest possible candidate universal generalizations that are consistent with research, categorize them, justify them, maybe seek some patterns, and then test against nature if possible. And some of this will turn out to be possible. I expect, I actually was going to take a screenshot of a database that I've been working on, but it turns out tables are really boring. So here's a different kind of table that's slightly less boring. So we've seen, this has been said a couple of times. These are all things that I've picked up from the literature in various places. Okay, that's troubling. Okay, so essentially anyway, the point is, that'll do it. Okay. The point is that we can investigate these. People have highlighted these. Okay. People have taken some time to point these out whenever they find them. This one, Steve Benner's said that in a couple of interviews. I don't necessarily stand by any of these. I just think that a lot of people should start thinking in these terms. Okay. Now, this might go contrary to what a lot of how we think normally of science. A lot of people don't want to make these wide claims about things. It's typically viewed as risky. But if science is about testability, then the broader the claim and the stronger you test it, the better science you're doing. I'm not entirely sure that's what science is about, but that's at least what we have to believe in doing science. So see, for example, this observation of an eclipse in 1919 that tested this theory by this guy. I tried to choose the pictures of these, of Einstein and Darwin that were more appropriate to when they actually developed these views, rather than the pictures of them with huge beards and crazy hair that we are so familiar with. So he proposes that gravity actually, that objects actually bend the space around them. And an interesting test of this is during a solar eclipse, stars should be slightly different from where we see them normally. And it takes a dozen years, but eventually this is observed. This is a wild claim. And when it's not refuted, it's corroborated. And so I'm proposing doing something similar to like that for biology. As this potential payoff. So a universal claim is falsified by a single counterexample. So any claim in universal biology should be falsified by a single. If you find one group set of organisms that prefers higher isotopes for no reason, then that seems to go against the claim that all life prefers higher isotopes, lighter isotopes. Okay. So by seeking these mechanisms, we can better get at this universality. This is doable to a limited extent. It'd be great if we had other examples of life, but since we don't, we should start thinking about what that would look like. Maybe make these claims that would actually be tested if we encountered life, rather than just trying to explore the evidence and seeing what it shows us. So in sum, we ought to systematically categorize this biology in a way that highlights the parts that might be universal. It should be this approach should be useful in that pursuit. And thank you. Join the wiki.